Hey guys, it's Andrew here. In the last couple of videos, we were looking at taking our addresses away from our classful addressing systems and moving into classless systems where we could have different address ranges. Instead of the /24 and the /16, we could have smaller or bigger addresses like a /25 or a /26. And we'd see that as we took more bits away from the host portion of our address, like a /24, and made it smaller and smaller, we'd make our networks smaller and smaller, but we'd increase the size or the number of networks that we had. All right. And that starts to bring us into this concept of really breaking it down into subnetting. At this point, we've really just been building up into the different systems of subnetting. Now we're actually going to take a look at breaking down this network into smaller pieces, right? So from henceforth, we're going to be given some network here, and I've actually written it out in two different colors, and it'll make more sense why. But we have 192.168.50.0/24. All right, and the real reason why this is in a different color is we've known from at this point in time that in a /24, these three octets right here, they're going to be locked in as our network bits, right? There's 24 bits here, lining up all three of these first octets, and then this fourth octet has all of our zeros in it. All right. So over here on the right-hand side, I've just written out our number line here, our binary number line. So we get our 128s are our most significant bit over here, 128, 64, 32, 16, 8, 4, 2, 1, all the way across. Okay, and this represents our 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so and that's these 8 bits in our host. So what we're looking at here, you've seen this before, all right? We're going to start looking at and is going to start saying, okay, well we have this, we have these 8 host bits, and we're given this network, right? We're going to be given an example. Usually it's going to be something along the lines of you're working for a company and you have to split your network up into, say, 2 different pieces. So down here I've got a little router, right? And I've drawn two spokes off the side, and this would represent the 2 different networks that I need to create. And just to keep it simple, we're going to look at this and we're going to say, how can we break this down into 2 separate networks, all right, to start? Now, we've looked at this in the past, right? We've looked at this a little bit, we've hinted at it, but how could we go about breaking this down into 2 separate networks? So at the moment, we have, if I write it out, we have that's our /24. So this gives us, let's put this here. This is, again, it's a base 2 system, and we have 8 network bits, 2 to the 8th, or 256 total hosts. Now remember, we lose the first and the last to the network address and the broadcast address, and while we don't always talk about it, again, on a system like this with a router, we need 1 as our default gateway, so kind of lose 3. But just for formality's sake, we'll say we have 256 total, and when you're going to set up the network, you would lose 2 right away to the network and to the broadcast. Okay. So we have 2 to the 8th host bits available. So remember, if we made this a /25, right? If we borrow a bit here, let me borrow a bit. Okay. I'm going to take this, and we are going to make this guy, hold on, there we go. I'm going to make this guy, we're going to borrow a bit, okay? And it's no longer going to be 2 to the 8th anymore. It's going to be, we're going to have 2 to the 7th, right? Now we have 7 host bits, all right? And if we have 2 to the 7 host bits, we have 128 hosts per network, okay? But remember, we started, if I kind of draw a box here, all right, imagine this rectangle here represents this network up here, right? So let's say this network up here is represented by this rectangle, okay? That entire rectangle represents my 192.168.50.0/24. But if I took that network and I made it into, I took this /24 and I took a bit away from the host portion and I gave it to the network, that is equivalent of, that 256. If I divided this 256 by this 128, I would get 2. Or better yet, if I take away a bit, I've cut my total network size in half. All right? So it's kind of looking at it like this. If the whole thing here, if this entire thing, like this guy, represents my 256, right, my /24, then these two, by making this, by borrowing a bit and giving it to the network address, right, making it a /25, this is like, it's like cutting this in half. 128, 128. All right, and this would be 2 /25 networks. Okay, and that's really what we're starting to look at here. In the previous videos, I said, hey, what if we took this and we borrowed another bit, right? Instead of making this a /25, let's borrow another bit. And let's make this a /26. All right. 2 raised to the 6th, right? We now have two network bits. So we have a /26 and 6 host bits. So 2 raised to the 6th is 64. All right. And if we divide that by 2, divide by that, we have 2, right? So inside of here, that would be like cutting the halves in half, right? So we could kind of just, let's go around it right there, right? Cut that in half. And that creates 2 networks of 64 apiece, all right? But that also, that splits the 128 in half, right? And as we continue to go down the list, we start to see that every time we borrow a bit, what we're going to be doing in a class C as we move further down, right? We move to a /27, there's /26, 27, 28, 29, 30, right? As we go down the list, we'll keep on dividing or cutting in half the size of our network, all right? And then essentially increasing or doubling the number of subnetworks that we have to work with. In this example down here, all right, we can see that we had these 2 networks, right? I needed 2 networks. And in this one, I didn't say what size networks I needed. So this guy here, just borrowing 1 bit for this /25 would have worked, right? I would have been able to create 2 subnetworks given this /24 network. Okay, so we're going to spend a little more time with this, but I did want to give you just a breakdown of what's going on here. Now we could play with the math a little bit more here, if we wanted to. If you wanted to figure out, given a certain number of addresses, right? If we have if we're given 2 to the 8th and we start with 2 to the 8th, right? And let's say I borrowed 2 bits, right? And now I have 2 to the 6th host bits. I can turn around and say now I have 2 to the 2nd network bits, which is 4, and my 2 to the 6th is 64, or I have 4 networks of 64, right? So you could play around with it that way. If you just prefer looking at the division, this works fine too. If you took these 2 values right here, right, and multiplied them, you'd get your 4 networks, right? 4 networks of 64 inside of your 256. You can really twist and play around with the numbers quite a bit here, but what we're really looking at is how many times can we divvy up our different numbers to get different size subnet masks, all right? Or sorry, not subnet masks, my apologies. Different size subnets, okay? Again, that subnet mask does tell us where the network portion of the address is and the scope and the range. And as we borrow more bits from our host and give it to our subnet mask, we're gonna decrease the size of our network, but we're gonna increase the number of networks that are at our disposal. All right. So in the next set of videos here, I'm going to take a look at a little trick called magic number. And it's used very heavily in C class addressing. You can also use it in B and A class addressing. There is one extra trick beyond that. But we're going to take a look at a few more patterns here in this magic number to help us figure out a quick and easy way to determine how many hosts that we can fit inside of a given network, right? Do remember that we have here I have 128 total, but I always lose 2 to the network and the broadcast. So maybe I could fit 126 total here, 126 total here. We will notice over time that we won't get this perfect. We may lose a few addresses here and there. We might have some leftover addresses. It's not a perfect science. But we will do our best to make our networks as small as possible and condense them down so we have the least amount of waste. Because at the end of all this, remember that IPv4, it only has, total, it's a 32-bit address, so it's roughly about 4.2 billion, a little more than that. But again, at the end of the day, we generally only use A, B, and C classes of the address ranges. D is reserved for multicast, and E is just reserved, right? So, we have to be as conservative as possible with IPv4. At the end of all this, when we get into IPv6, we'll be able to just, use as many IPv6 addresses as we want to. But for now, we have to be as conservative as possible with IPv4, all right? So in the next video, we'll take a look at that magic number, and we'll take a look at its significance and how we can use it to easily identify, given a requirement for X number of hosts on a network, and given some type of network address, how to quickly solve and break up our networks in an easy way. I'll see you guys in the next video.